OMG, let's revise 1.12 respiration. In this, there are 7, core knowledge questions. Pause the video and attempt them. Okay, so let's go through the answers. So number 1, the word equation for aerobic respiration is glucose plus oxygen gives carbon dioxide plus water. Number 2, anaerobic respiration is glucose, arrow, lactic acid. You can have it release as energy here as well. 3, the oxygen required to break down lactic acid is known as the oxygen debt. 4, gas exchange takes place at the alveoli in the lungs, between the alveoli and the capillaries. Number 5, name 3 adaptations of the alveoli. So it's thin walls, large surface area, and then a close blood supply. Number 6, smoking. How does it damage cilia? They're damaged or burnt and cannot trap the dirt and dust. And finally, number 7, list the diseases caused by smoking: bronchitis, emphysema, and lung cancer. Okay, so attempt these 2 past paper questions, pause the video, and then we'll go through the answers. Okay, so let's walk through the first past paper question. Tom jogged 20 minutes and you've got a table showing the time goes all the way up to 20 minutes and the concentration of lactic acid in the blood. Part A, how many minutes after the start of the exercise was the highest oxygen debt recorded? Okay, so we're looking for the greatest concentration of lactic acid in the blood. That's 44, and that corresponds to the 6th minute. What type of respiration results in oxygen debt? It is anaerobic respiration for that mark. Okay, part 3, when would Tom be releasing most energy per glucose molecule? And explain your answers. So remember, 2 points here for 2 marks. Most aerobic respiration occurs at the beginning, 0 to 2 minutes. Okay, so that's when the lowest concentration of lactic acid occurs within the blood. And part B, which type of muscle cell would be producing lactic acid? And the answer is muscle, to put that in the box. Okay, so the second past paper question here, we've got a table. Again, it's going up to in minutes, 60 minutes, so within the hour. And you've got 2 people here, okay, the athletes showing their lactic acid concentration. So use the data to give reasons why Anjem appears to be fitter than Tudor, and Anjem produces less lactic acid, okay, for 1 mark. Remember, it's 2 points for 2 marks, and it's broken down quicker. Okay, because you can see Tudor here produces 90, okay, in comparison to the highest being 80, around 10 minutes. And at the very end, it's broken down quicker. You can see with Anjem's, it goes down to 25 by the end of the hour, whereas Tudor's still remains at 50. Okay, so it's twice as high. In part B, give a reason why a marathon runner relies almost totally on aerobic respiration and produces very little lactic acid. For 1 mark here, does not need to release energy in a short time like a sprinter. Okay, so more past paper questions. Pause the video, we'll go through the answers. Okay, so in the first question, it says complete the table to show the decrease in chest measurements for trial 1 and 3 that weren't completed, and all we're doing is taking away. So 105 minus 90 is 15, and then at the trial 3, 104 minus 91 gives us an answer of 13. Both of those need to be correct for that 1 mark. So in the second part, it says calculate the mean decrease in Roger's chest measurement when he lifts the weights, and it must be in 1 decimal place. It's 2 marks. Okay, so a correct answer is 14.3 centimeters. So that 1 decimal place, so 0.3. And you get, in your equation, you get 43, okay, by adding up 15 plus 13, and then you're dividing it by the number of times. So you get 3 trials. So 43 divided by 3 is 14.3. Okay, so part 3 says complete the table below to show what happens when Roger's chest, when he breathes out. Okay, so we're talking about expiration using the words that are given. It's 3 marks. We're given that the diaphragm moves upwards, the rib cage movement is down and in, volume decreased, pressure increased for the 3rd mark. Okay, so moving across, we're asked to label the structures A and B on the diagram. So A is the trachea and B is the bronchus, okay, or bronchi together, but this is specifically looking at the left bronchus. Describe the movement of the diaphragm during expiration. So again, this was 3 marks, similar to the other question. The first mark being the diaphragm moves up, so it's domed. The volume decreases, and then the pressure increases. Okay, so final past paper questions. Pause the video and give them a shot. Okay, so we start off by being asked to label A and B on the diagram, anatomical structures. So we have the trachea in part A and the alveoli. Okay, it's not the bit before, which is the bronchiole, but it goes down to those millions of air sacs, the alveoli, for the second mark. In part B, okay, it says while a person is breathing in, the volume of lungs increases. Describe the movements of the diaphragm and ribs as they bring about an increase in volume. Okay, so it's 2 marks, so 1 for each. The diaphragm flattens and moves down, and the ribs, they up and out. Okay, move up and out. In part 2, here it says, how does the pressure in the lungs change when the volume increases and the pressure decreases for that mark? Moving across, we have a diagram showing a single alveolus. And for the final 2 marks, it says describe 2 ways in which the structure of the alveolus is adapted for the function. So those adaptations, you can have a large surface area for 1 mark, a thin wall for the second mark, or if you've written closer blood supply with those blood capillaries. And that's the end of the video.